In this lesson, you'll learn to work with Nano. Like with Vim, volumes could be written on what you can do with Nano. We'll cover some basics to get you started, and that may be all you need. A quick look at the help file shows that there's quite a bit there. It's pretty extensive. Like 255 lines, quite a bit of stuff you could do. The easiest way to learn, though, is just to start using it. Just type nano and your file name, and then hit enter. Just like with Vim, if it already exists, it'll open it. If it doesn't, it'll be created. Nano is also a text-based editor, but it has menus to walk you through the commands. It also makes use of hotkeys, keys which are paired together, so Control-G brings up the help menu. The Alt key is also used. Commands that require control have the caret in front of them. The caret is the little thing that looks like the roof of a house, or kind of an up arrow. It's above the 6 key on the North American keyboard. Things that require Alt are represented by a capital M. Whenever you're doing your work, Control-O will write your changes out. Once you're in Nano, you can edit text as you normally would. Just type to add text, use the up and down arrows to move around, use backspace to delete. If you want to find something, you hit Control-W. Then type the text you want to find and hit enter. Hit Alt-W to see the other instances of the thing you're looking for. Use Control-K to cut a line. Scroll down to where you want to insert the line and hit Control-U to uncut the line. If you have a really long line, it won't wrap by itself. Use Alt-Shift $ to wrap the text. You can go to the beginning of your document by hitting Alt \\, and to the end by hitting Alt /. So \/ for back, / for forward. Type Control / to do a find replace. Once you type Control /, you'll enter the word you're searching for, hit enter, and then the word you want to replace it with, and hit enter again. You'll be prompted each time unless you hit A for all. Here I quickly find and replace the word the, replacing it with zoology. Just so you can easily see the changes. Then I quickly switch back and replace all the zoology with the. That's it for Nano. There are many more things you could do. Please practice both Nano and Vim. Get comfortable with them. And have fun. See you in the next lesson. Since you know how to edit files with Vim and Nano, I want to help you avoid some pain and suffering by showing you how you can keep the original of any system file you may edit and subsequent versions as you modify it going forward. I wish I could tell you I read this somewhere or I learned it in a course as you are, but no, I modified a configuration file in an Nginx web server and didn't have the original or a previous version to fall back on. If it were a simple edit or two, no big deal, but the editing was extensive, and having saved and exited, I couldn't use the undo feature. To get an original, you may be able to just copy from another server or a clean build provided it's running the same version of software, but that takes precious time. You should also have backups of any production server, but again, restoring from backup or finding a file in backups takes time. Short of using a full repository for your files like Git, how can you keep an original and versioned changes of your system files? The solution is simple. Before you edit, make a copy. In this example, we're going to use a file called sshd_config. It's a file we'll be editing in a later lesson on securing SSH. So we're going to make a local copy of this so we don't damage the original in its original location. So we'll do cp etc ssh sshd, and then we'll just copy it here. So we'll do an ls, and we see sshd config is there. So we know we want to edit that, so before editing it, we'll make a copy. We'll call it sshd_config.0. So sshd_config.0 becomes the original, and then we'll edit sshd_config. And one of the things we'll do in this file is make sure that root, we'll cover this in the lesson, so please don't worry about it right now, but make sure that root login is disabled. So we're going to explicitly disable that. And then we'll write the changes and quit. So now we restart our SSH service and our server doesn't work for some reason. We were smart enough, or let's say experienced enough, to keep this session open and open a new one to test SSH, and we found that we couldn't log in. So we know we just made a change to that file. Let's see if we can figure out what that was and see how to restore quickly. A tool we can use to do that is called diff. All you do is type diff and the first file name and the second file name, and it'll show you what's different. So in the old file on the bottom, it said permit root login prohibit-password. In the newly edited file, it says permit root login no. So if we want to test and see if that caused the problem, we could just restore. And before we do that, if we had made a lot of edits on the new file, we could make a new version of it by doing copy sshd_config sshd_config.1. So this is now the new version, and 0 is the original. Then we can move sshd_config.0 to sshd_config. So sshd_config.0 will no longer exist, but it will have overwritten sshd_config. Now if we diff sshd_config and sshd_config.1, we'll see the change in reverse order. In other words, the change is in .1, but it's not in the original. So we do diff sshd_config and sshd_config.1, and we can see that in the present file, sshd_config, prohibit password is under permit root login, and in the one that we saved as sshd_config.1, permit root login is set to no. So if I were in this present situation, because I always like to have a copy of the original and we're back to the original, I would again do copy sshd_config sshd_config.0. So now we have the original, which is the same as the present running version, but if we do make a change to the running version, we have the original to fall back to. So we have 3 different versions of the same file. We have sshd-config and sshd-config.0, which happen to match right now, and sshd-config.1, which has some modifications to it. So if you find your directory getting out of control with all these backups, you could delete some at your discretion. I would always keep the .0 and the latest version though. So if you have sshd-config.0 and 1 through 5, I would keep 0 and 5 at a minimum. So you know what the original is and you know what the latest revision was before the current version. So now you understand how to do simple versioning on your configuration files to save yourself a lot of headache down the line. Now we're going to talk about the Linux file system. One of the things that people find intimidating about the command line is just getting around. How do you know where you are and where to find things? There are a few tools we'll use that can help. One is the File System Hierarchy Standard. So if you go to pathname.com, you'll see FHS 2.3. You could look at that in HTML or PDF. We'll go ahead and look at the HTML version. So it tells us at a high level what the directory structure is and what should be in each directory. This is a directory structure that should be fairly common across Linux distributions. Another nice option that's built right into Ubuntu, meaning you don't have to go anywhere to look for it, is the hire man page. You type man hire and you get a man page telling you what the hierarchy should be. So the first / is the root directory. Next is the bin directory. This is for binaries or executable programs. These are programs that are needed in single user mode, and we'll talk more about single user mode in a later lesson. There's the boot directory that has static files that are needed for your bootloader, which is grub in this case. Grub looks in this directory for the boot files it needs to boot up your system. The dev directory has special or device files that refer to physical files. The etc directory has configuration files. We'll take a look at the etc directory in this lesson. The home directory is usually where users' home directories live. Lib is a directory that should hold shared libraries that you need to boot your system and to run the commands in the root file system. Media is a directory that contains mount points for removable media such as CDs and DVDs or USB drives. MNT is a directory for temporarily mounted file systems. OPT should have add-on packages that contain static files. If you install something yourself and it's not in your package manager, this is the place to put it. Proc is where your proc file system is mounted. It provides information about running processes and the kernel. Root is usually the home directory for the root user. The home directory for root is usually not in the home directory where other users' directories are stored. It's in /root, right off the root of the file system. SBIN holds binaries too, but these binaries are usually not executed by normal users. SRV contains site-specific data that is served by the system. Sys is the mount point for the sysfs file system, which provides information about the kernel, similar to proc. /temp is the directory that contains temporary files which may be deleted with no notice. Don't store anything you need in the temp directory. /user holds shareable read-only data. User bin is a primary directory for executable programs. Most programs executed by normal users, which are not needed for booting, are stored here. And we'll have a look at that directory in this lesson. var is an important directory for administering your system. It contains files which may change in size, such as spool and log files. So you remember in several lessons we referenced var log. Var log has a lot of things that help you troubleshoot issues on your system. var www is where you'll have web-related things if this is a web server. So that's it for just scrolling quickly through the Hire Man page. Let's have a look at the actual file system. You can visualize the directory structure as a kind of a tree with root at the top. So if we cd to root, we can see the directories here. But there's a free tool that'll help us actually visualize this as a tree. And you'll never guess the name. It's called tree. So to install tree, you go sudo apt install tree. And to put in your password. Now I've already installed it, so it didn't install it for me, but when you go to install it, it'll ask you if you want to install. It's a pretty small program, and it's great for following along in the lesson if you want to download it. The command we'll use here is tree -d to only show directories, and -L 2, so it'll only go 2 layers deep. If we go more than that, we just get a huge amount of output, which isn't helpful to us right now. So let's try this, and you can see the directory structure. We're only going 2 levels deep, so the root is at the very top. There's bin, boot, grub, dev and all its subdirectories, etc with all its subdirectories, home with the user directories, lib64, media with a CD-ROM directory, mount, opt, proc, many of these subdirectories are directories for processes that are running on the system. We can't read that because we didn't run as sudo. Only a root user could read the root directory. Run, sbin, snap, service, sys, user backup, user, and var. So 333 directories. If we go a level deeper, we'll see that'll get really huge. 1,800 directories, and again, it just gets more cumbersome to look through. But you get the idea. There are directories starting from root, and subdirectories as deep as you want to go. Now we'll look at a few of the directories you're likely to use most often. We'll start with etc. So we can see there's a lot of stuff in here. Apt is in here. Cron for running scheduled tasks is in here. LVM for Logical Volume Manager. Kernel. Network. System Control. Sudoers. SSH, SSL. Security and Linux. Many programs critical to your system are in the etc directory. If you install packages, there's a very good chance that some of that package will live in the etc directory. Let's look at the home directory. So again, this is where users' home directories usually reside. Remember, the root home directory is different. That's right in the root of the file system, and it's just called root. We'll take a look at the opt directory. There's nothing in there usually by default. But if we install a program like Linus for evaluating the security of our system, this is the place we would put it. And the last directory we'll look at is var. The place you're likely to spend the most time is var log. Some of the logs you'll look at the most are the auth log, it tells you status of sessions for logging in, logging out. If you're trying to work with someone and you're configured SSH for them and it's not working quite right, this is where you go to look for what's going on. And syslog is another one that you'll probably use. Many system events go into syslog. If you install a piece of software like a web server or a database server, it will likely put some log files in here for you too. So that's where you would troubleshoot those. So that's it for our high-level tour of the operating system. Please browse around and get your own feel for it as well.